This conference will now be recorded.
Yeah. So first thing, what is Kubernetes? So what is Kubernetes? I'll put it in this way. Kubernetes is a pod orchestrating tool, or you can say container orchestrating tool also. Okay. Now orchestrating means what? Anyone have idea what is the orchestrations means? What does that mean? No. Let's say running at the large scale and managing it, being planned at the large scale, that is called, that maybe you can call orchestration. So Kubernetes is a container orchestration tool or pod orchestration tool. I'll talk about what is a pod in later point of the time, but if you have studied Docker, that means you know what is a container. Now this is written in Golang, okay, and by Google, donated to CNCF. First release has happened somewhere in 2015. So this is something which we have about a Kubernetes. Now you must be thinking, why we need Kubernetes? Why Kubernetes? Okay, what is the reason for it? So if you want to understand the reason for why we are running Kubernetes, you need to understand the limitation of Docker. Okay, this is something which you have to understand, limitation of Docker. So let me put it in a pen. So let's say, think about it, and you're going to tell me this answer. There is a one host, okay, and there is another host, and here is the IP address of host. Here there is a container of Docker. Here there is a container of Docker. Here there is a container of Docker, and here. Now all this container is only Apache. Only Apache. And here, this is the load balancer we want to create for the Apache container. So do you think all this 4 pod can be load balanced by the container? Do you think? Tell me.
If they are accessible to load balancer, yes, otherwise no.
How can we access?
By port forwarding maybe, I don't know.
Okay, good. So I forwarded this one at 80 port of node port. Here this one also I did the same thing, 80 port at node port. Now this load balancer I am setting up with this 80 port and this 80. Okay. So now can I port forward this one also at 80 port?
No.
Then how can we load balance this container? Are you thinking about it? Are you thinking about it?
Yeah, it seems to be not possible. Maybe we have another load balancer at.
No, but it's Apache. No? It's Apache.
Yeah.
So this is the limitation of Docker, one of which. Second limitation. See, container is managed by whom? Docker. Now, when you get a multiple machines, you want to run more container, you will add more host. You will add more host. Now the question is, who will manage? See, container is managed by Docker, but the question is, who will be managing the multiple Docker host? Who? Let me delete this. Who will manage? You are running the container in the production large scale in data center. So who will manage the container? A Docker, multiple Docker. Should be having one tool for it, right? That is also Docker. Docker cannot do that Docker management. That capability Docker is not having it. So we need a tools like Kubernetes to solve the networking problem, to managing the multiple Docker host. We need to solve this problem. So we need a Kubernetes. Another problem which we have is there are many problems actually in a Docker container too. There's no problem with the container, but when you use container at the production level, then we have a many problems, many challenges, many features which we want, which is missing in Docker. Okay. Now what has happened? What has happened? Think about it. These all are running in the production server, and suddenly this node got offline. This node also got offline. So now four container is missing right now. So earlier my production was running on the eight container. Now it's running on 4 container. So my response time will go up for my end client. So who would fill remaining 4 more containers in this box or maybe some other box? So the load response time will be the same as earlier. Who will monitor that? Monitoring, we can call it monitoring. Okay, who will do that? Do we have any tools for it? Docker cannot do that. So for that scenarios we have a Kubernetes. So here are some of the scenarios which we have the limitation of Docker, and for that we are using Kubernetes. Okay, so yeah, limitation of Docker allow you to get the Kubernetes. All of you are understanding at the high level?
Yes.
Can you repeat, please?
Yeah. So there's that. See, Docker manages the container, and container you use in your laptop or VM. Very nice. Everything is so great. Within a second you get a container. But when you bring the container at the production level, where we are running the container in thousands and hundreds of hosts, that is where lots of management capability you need it in terms of storage. You need some functionality in terms of networking. You need functionality in terms of monitoring. You need functionality in terms of reliability, high availability, scalability. All these things you need a functionality which is lacking in Docker. And that is why the Kubernetes has come and said, okay, I will solve all the production problem, which most of the production problem, not all, which with a container, and you can use me. That means in a simple way, if you want to run container in laptop or VM, you can run it just like with the Docker. But if you want to bring the container to the production level, you have to have a Kubernetes, because to manage the container environment at the production level, Kubernetes has all these features. Make sense?
No, sir. Thank you.
Yeah. Now, guys, if you really want to understand a little bit more in detail, okay, so there is just only on this part, why Kubernetes. Okay, there is a 1 hour of recording. You will get it only on this point in LMS. Okay, so I'm not dragging too much right now because focusing on the real demo. So yeah, what is Kubernetes and why Kubernetes? This is the stuff. Now, next question is architecture of Kubernetes. Okay, architecture of Kubernetes. What are the architecture of Kubernetes? So guys, in architecture of the Kubernetes, we have human, you and me, and we work on workstation. Okay, workstation we call it, and here from workstation we send the request to master server. So this is the one machine, and this is another machine, master server, and then master send the what is the instruction or to the worker, and here it can be multiple workers actually. So this is a workstation, this is a master, this is a worker. Now all these things we have. Now this together we call it a cluster, Kubernetes cluster. In short, I'm writing it Kubernetes cluster. So if someone will ask you what are the kind of nodes, this is the one node, this is a multiple node you may have it. What kind of node you have in the cluster? So you can say, hey, there is a master node and there is a worker node, and there may be multiple worker, depends on that how many pods or how many containers you want to run, how many containers. Okay, and master also can be a multiple actually.
I'm sorry for the interrupt, Rajesh. So here node is nothing but server, right?
Node means this is also one node, right? This is also one node. This is also one node. Node means server, yeah, correct.
Thank you, Rajesh.
So this is your laptop node. You can say like this. Okay, this is your laptop. This is the master node. This is the worker node. So this is how it is. So lots of architecture can be done. Okay, but this is at the high level, and this together we call it cluster. So in a cluster you will have a master and a worker node. Now next thing is then you will ask me, Rajesh, what I need to keep it in workstation so I can send request to the master. So in the workstation you have only one utility, kubectl. Okay, you have one utility called kubectl. So what is this? So kubectl you can say is like a client, is a client, okay, which connect to the master. Now, so then next question, what are the component in the master? So master, you will have a multiple component. So these components which you have is kubeadm, you have kubelet, you will have Docker, you have kubectl also. Okay, so these are the tools actually. This is the tool, this is also tools executable. Okay, but there will be some services also running. Which are the services? API services. Now you will have etcd services. You will have controller manager services. And we will have scheduler also. These are the applications. So you can say this tool utility you need to install in master, and these are the application need to be run. So here you can have core DNS or DNS services also. Okay. So these are the 5 services you will have in the master. Okay. Now these utilities you have to have in master. Now next thing is what component will have in the worker. So in the worker, tool wise everything will be same. Okay. Tool wise everything will be same, and tool wise everything will be same. The component wise this will not be there. Okay, so there's one component UPS server, etc, controller manager, scheduler, TNS, and proxy I missed it here. Okay, so here proxy. Now this will not be there in the, okay, so in the worker only this component will be. So now the questions here. So you got the workstation here, you got the master here, you got the worker here. So in workstation you will have a kubectl utility installed, master you will have this many, and worker also same, but in terms of services this one will be different and this one will be different. So this is the mapping of services and tool. But you know what, guys, recent version of Kubernetes, they have removed the Docker support by default. So for that, you need to have a container D also. Actually, container D was already earlier also it was there, but now I'm mentioning because you need to know that. So yeah, container D also will be there in this one. That means now Docker is not managing the container in Kubernetes. Container D will manage that from the latest version default. Okay, so now the question is, what exactly these utilities are doing? Correct, huh? All of you? Correct?
Yeah.
So here, kubelet, yeah. So kubelet is an agent running in each node. This kubelet, see kubectl you have in your laptop, but in master and worker you have a kubelet. This only, this agent only create a cluster actually. So this is the agent running in each node, and also pod management is done by pod. See, container lifecycle, which you remember that container lifecycle. Container lifecycle means create a container, start the container. Remember?
Yes.
Correct. So something like a pod lifecycle is managed by kubelet. Now, what is a pod? I'll just tell you in some time. Just give me some time. So I'll tell you the pod. So pod lifecycle is being done by kubelet only. Now Docker, what exactly is doing? You know that container management and stuff like that. Okay, so here pod is being managed by kubelet. Container is managed by container runtime. You know that. Now container D also now from the latest version of Kubernetes will do the same thing. Runtime interface for container. Now kubectl is a client which we discuss here for connecting API server. Okay, and what is this kubeadm? So kubeadm is admin tool, Kubernetes admin tool. So you know all these services what you get it here will be created by kubeadm. Okay, so more or less we understand the use of this. Now we have to understand use of this. Okay, so let me show you through the visualization. It will be easier. So now let's say this is my laptop and this is this is you. So here theoretically kubectl is installed here. What I did, I don't know. So kubectl will be installed somewhere here. Okay. After that, we have a clusters. In the clusters, you have one server called master. Here is the master. So master will have all the utility installed. So here I'll just draw. Here you have a kubeadm. Here you have kubelet. Here you have kubectl, and here you have Docker, and here you have a container D. Few more are there not required to discuss. So this utilities has to be there here. You can install through YAML, apt, or manually also you can copy this file. Then these services will come. So these services will be created by kubeadm. I'll show you. So sorry. So here, this is the API server. This is the etcd. This is the controller manager, and this is the scheduler. 4 component I just said, no? Few more components are there. Let's keep it aside, right? So what is the work of API server? So I'll put it in a simple way. Any request you send to the Kubernetes, you send to API server. Any request. Okay, any request anyone sent to Kubernetes cluster, everyone sent to API server. So this utility also talk to API server. This utility also talk to API server. This utility kubelet is a kubelet also talk to API server. Proxy which you have also talk to API server. So internal and external communication, everything is API server. Will you remember that?
Yes.
Yeah. So you got the request, internal and external, everyone is API server. So API server is very important. Now API server receive that all the request or whatever it is, request and status from internal component and stored in the database. This is the database. This is the etcd database developed by CNCF. Spend some time on this website, okay? So Kubernetes also CNCF. etcd also CNCF. Prometheus also CNCF. Many products they have. Okay. So this is the etcd key and value based database distributed and all. Very wonderful. So now after that, what happens? This controller manager, this check the entire cluster of worker. I'm just putting in the high level. This is worker and this is a worker also. And here all this component in the worker will be same. Here only the services which will have here will be proxy will be here and proxy will be here. So this is the kubelet. This is the kubelet. Here you see that kubelet, which is the agent running in each node of the cluster, and proxy will be there also. This services. Proxy is the networking services. Okay. So this is the networking services. This is the DNS services. So what will happen? So controller manager will submit a report about the cluster to the API server, and if there is a mismatch between the human desire and actual, then API server will ask scheduler schedule the request to worker, and worker here receive the work. Kubelet is the agent which is receiving the work and instantiating a pod. Here if you see that kubelet only instantiating a pod, see here, and ask Docker to fill the container. Now container D is required, Docker is not required anymore. So it's like this. So pod is being created by kubelet, instantiated by kubelet. Container is filled by the container D. Earlier it was Docker, and network is been given by proxy. So proxy is a networking services. So far these are the flow which happens. By the way, you don't need to know in depth as long as you are administrator and all. But yeah, this is the stuff. So now next thing which we are discussing in this whole architecture, what is pod? Correct? So at a high level, did you understand all of you? This one.
Yes.
Yeah. So guys, for this architecture also, we have almost 1 hour of discussion along using the slides, in LMS, please spend some time. Now I am focusing more on Kubernetes because you have to understand Kubernetes as soon as possible, because Kubernetes is the only runtime environment where means container or pod runtime environment which every organizations are using now. So you have to upgrade your skills. Okay, so now the question is, what is a pod? So I'll put it in a very simple way. Let's say here you install the VMware. So VMware and then install the Docker. So VMware manages what? Tell me. VMs, correct? Correct now?
Yes.
So Docker manages what?
Containers.
Container. So guys, same way, Kubernetes cannot understand the VM and container. So Kubernetes manage the pod. That means if you go to the Kubernetes, don't say container. Kubernetes manage the pod. Then you will say, Rajesh, you are talking about the container orchestration, and then now you are talking about the Kubernetes don't understand the pod. Yes, that's true. Pod is instantiated by, as I said, kubelet here in the image, kubelet, and pod contains container. Yeah. So basically, Kubernetes directly not interacting with the container, but pod. So pod basically is a logical unit. It's not a physical unit. This few statement which I'm telling you is very important. Pod is a physical unit. That means you cannot go inside a pod. You cannot go inside a pod. You cannot see the logs of pod. Okay. Pod has a container. You can go inside a container. You can see the log of container. All this thing is, you can see that. So what is a pod then? So what has happened? In order to fix many problem of networking, storage, and this that, and in Kubernetes environment, they put it the container and attached to the pod. So pod is a just a, you can say it's like a identification for the pool of resources, and which may have support. You may have a multiple container, multiple volumes, and many things. So here that is what is there in pod is. So in Kubernetes, when you go, then you have to work with the pod. Pod get IP address here in Kubernetes. I don't know how much you understood, but yeah, just like a VMs we manage by VMware, container managed by Docker, pod is managed by Kubernetes, and inside the pod you have container. The container is running, pod is running. Pod cannot be created. Pod can be instantiated only. You don't have a stop, start, and all. Pod cannot be started. So how come the pod is running? So as long as the container is running, pod is running. Container is not running, pod disappeared. That means same pod you cannot get it again back. Similar pod you get it. So not a same pod you can ever get it. Once the pod is disappear, means gone, permanent gone. Are you
One
understanding?
question
So,
I have on pod. Yeah. So you mentioned that it gets assigned the IP.
Yeah.
So how does that work with so container should also have the IP, or so the IP
No,
of container is no?
no. Container do not get IP. So here pod gets IP. That
But
means
how it communicates in that case?
uh, two. So how multiple containers you can have in the pod? Okay, multiple containers. So now the question is how it communicate. So all this container uses the pod network to connect with the entire cluster within or outside also. Okay, I'll
It
put
is
it.
a kind of a network layer only.
Mm,
Configuration and network layer.
yeah. So if you go to the Docker networking topic, okay, probably that will be the good start. So in the Docker networking topic, I don't know how many of you have gone through. So in the Docker networking topic, a container can get attached to host network also. Okay,
Yes.
container get IP address also and can get attached to the host network also. So that is the stuff. So here this container do not get IP address. What they do, they attach to the network which is at the pod level. Something similar. I'm just trying to correlate. Okay.
Okay, then how would the traffic be distributed here in that case? Like,
I will hold this question for some more time. Okay.
okay,
I would like to answer, but because I don't want to answer this one, because the things will get complicated, because it's not basically a 4 hours course. It at least 5 to 6 days or 7 days or something. Yeah.
So,
So I'll just
Rajesh,
hold it. Hmm.
so ultimately you mean to say that container in Kubernetes is always associated and will run under a pod.
100% true. That means you should not talk about the container anymore. You should only talk about the pod in Kubernetes. So inside a pod, you have a container. And if you want to talk to the pod, you can talk to the see, this is the logical unit. Logical means I'll put it in this way. How to put it? Okay, I got this. So here, see, can you touch the earth? Can you touch the earth?
yes,
Can you touch Apple? Can you touch speaker? Can you touch laptop? Yes. Laptop generate a waste.
Yes.
Apple also generate a waste. Earth also generate. I mean, I would not say Earth, Mother Earth generate a waste, but yeah, in a simple way to try to understand. So that is physical entity. Earth is a physical entity. Mobile is a physical entity. Laptop is, you are also physical. I can touch you. I can touch and I can feel it. But can you touch a sky? Okay. No. So, but still we are inside a sky, right? Correct, no? Correct. Think about in the those stuff. We all are inside a sky, but we cannot touch sky. So it's like that. Pod is a logical way to manage the containers. So a pod is just a logical definition. It's not creating any burden on the CPU and RAM and all. Basically, container consumes CPU and RAM and hard disk. So a container runs with application, and if container is running, pod is running. Container is not running, pod is gone forever. It's gone forever. Are you understanding? We'll see. There's something which
Right.
we are talking about, but something we'll experience sometime in a Kubernetes also. Okay, so this is the pod. Now, this is the pod. So what is a pod? I gave it to you answer at a high level. Now, important thing is how to set up a cluster. Okay, so guys, hell lot of ways is there. Hell lot of ways. So don't get lost. I'm telling you with a strict statement. Don't try to learn all the method in Kubernetes. There are more than 40 methods are available. Using that, you can set up a cluster. You should not focus on set up a cluster. Any one way you can get it, start working on it, because after the setting up the cluster, you will get everything same. So whether you set up a cluster using EKS or AKE or GKE or COPS or kubeadm or minikube or this or that kind, so many utilities are there, so many platforms are there, so many automations are there. Don't get lost. Focus on learning first, then focus on the different installation configuration, because you will lose all the time, you lose the energy, and then stop focusing on the real thing. So many ways to set up cluster. Now some of the ways which I am having it documented step by step, which I would like to share with you. So go ahead with it. So here EKS will be, I think it changes every 6 month step, so I think it will not work. So let's focus on the something which is kubeadm. Okay, so here if you want to set up cluster in CentOS 7 and using kubeadm, which is the official utility for, remember, kubeadm has to be there here also and here also. It's official utility for setting up cluster. So if you want to go for that, then go for this documents. Okay, now if you want to do in Ubuntu, then go for this. Okay, I'll not share something which I have not tried in last 6 months because steps get changed. So try this one in CentOS 7. This I have not checked actually from last 6 months. So unnecessarily, I don't want you to waste your time. This is also good. This is here you use with the Docker, okay, older version of it, and here you use containerd, which is a new version. So here this is the containerd. Okay, so yeah, so 1.236 version will be installed in Ubuntu. So this is for Ubuntu. Okay, so right now I'm going to go and install the latest version of this containerd, because anyways going further you will not go back and do something which is the older version. But if you want to learn, you can go for this. Again, everything behavior will be same no matter which cluster you are going. So yeah, I'll show you the setup with this document in Ubuntu. So let's go for VMware. No, VirtualBox. So actually I have a cluster setup already. I can use that one, but I want to show you how to set up, so at least you'll have some confidence. So where is Ubuntu? This is the one. Okay, so clone Ubuntu Kubernetes master. And one more clone worker. So 2 machine is okay for this. In fact, 1 machine is also okay, but at least I want you to experience the 2 machine, 1 master, 1 worker. Okay, master and worker you can set it up in 1 machine also. Okay, so mind it. So this is the master. Let me start this. Root Rajesh 123 root Rajesh 123. It's not taking what? Problem which I think I forgot this. Okay, let me pause this recording.
This conference will now be recorded.
Yeah, so I'll just delete this because I forgot the password, and I'll go to the cloud. The cloud, sign in. Where is EC2? Yeah, launch instance Ubuntu 20. So here 22 is there. I'll go to the stick to the same version because I don't want to try in front of you. That if there is error, it's very difficult to again save time. So here I'll
So
go
recording
for,
is not started.
I started. So 2 CPU, 4 GB RAM, 2 machines I'm going for it, one for worker, one for 30 GB hard disk is sufficient for it. And next name Kubernetes, and here launching security groups. I'm opening up everything. So there is a Rajesh default, yeah, review and launch. So Rajesh Mumbai and done. So I got the 2 machines here, and these machines I'll be using. So let's rename it. So here this is a master machine and this is the worker machines. Okay, so master machines, I'm going to log in now, and you see that what steps I'll do that. So for that, putty I'll use, and auth. I have a ppk file somewhere in location here. Okay, open, accept. It's Ubuntu, right? Okay, maybe username was not root, maybe Ubuntu. It's okay. Move on. Okay, all of you can see that, right?
Yes.
Yeah. So now I'm going to set up a master here. Okay. So for that, I will follow these documents. So first thing, I'll download this code actually. Okay, this code. So git clone, and I'll become root actually. Okay, so this is the location, and git clone, and this URL, and it says not found. Of course, yeah, the URL is just a second. This is the URL. So git clone, I got it cloned here. These all are scripts here. Now this is the URL. Now inside this URL, you go to this place, cluster setup and latest. So cluster setup, and this is the latest, means 23 actually. Okay, and there is a script here, install worker, install master, chmod 755, install master, install worker. I just setting up the permissions. Okay, so this is something which you go, and you can also run this command also in the master. It's the same script actually, or you can run like this also, same. It's up to you. The script which you have is here. If you want to study the script, please feel free to study the script and get going. So this is the master script, and this is the worker script. Okay, so right now I'll not bother too much here and there, and install this script. So master, enter. So here it says sources not found. Sources not found means what? So Just a second. You have to change this one. Bash. I'll do one thing. I'll change online also after this. So SS to bash, this region is not. So run, and it will take I think 3 to 5 minutes to do everything in one go. So this we are doing using containerd, not a Docker. So Docker has been deprecated by Kubernetes. So maybe after few months, I'll include the this one, what is it, containerd in the course rather than Docker. So this will set up your master component. Okay.
Hello, can you send the link of the repository and maybe show which repository from where you're referring?
Here is you have a link in this article. I'll send it to you after this session. So this whole URL, this code is here. Okay, so while talking to you, let me correct this. This is the repository, and go to the master, and let me correct this bash and commit this for here and for worker also. Yeah. So I corrected this online. You will not face that issue what I had. So I'll share with you after this session in one notes all this stuff. So my master is set up, almost done. This is the last few minutes and done. Now guys, this let it happen. My master has been set up. Now guys, what you do, you know what? This one you copy actually, because I need this one in the worker. Okay, so here it's okay. So here if you see, it's been done. Okay, so okay, so I just copy this one also. I need it. Okay, so done. Master is done. So what to do? So guys, now we need to set up a workstation. This guy. So any questions so far on the master front? Any question?
Uh, just one question is, can we have master and worker on the same machine?
Yeah, possible. There is only one command we need to run. And let me, I'll whatever you said, no, I'm searching. Kubernetes master act as a worker. And only this command will help. this.
Oh, okay. Okay.
But right now I'm not, because I have not see, to be honest, the Kubernetes I have it 40 to 50 hours of course. Too much of content we have in Kubernetes. But right now my goal is is not to get you lost in the configuration customization. Rather than you start using Kubernetes, the fear will come out of you and then you go into the customization. Got it? It's a huge platform actually.
Yeah.
Okay, so yeah, so I copied all this thing, and now I want to create a workstation. So guys, if you notice, kubectl was here, no, in the each master, correct? Correct, no? Remember?
Yes.
Rajesh, can we have a couple of sessions regarding this in that case?
So 20 to 30 hours of recordings for the previous one. There was one dedicated batch for Kubernetes only, and I had a 20 hours session plus session. So that is there in the LMS. You can check this out also. But one more thing, I think next month a dedicated CK batch will start, means Kubernetes certification. So that will be around 20 hours again. So if you want that one also, you can join.
Yeah. Okay.
Okay, so I'm doing very simple thing. So kubelet was in the each machine, kubectl, sorry, kubectl. So it has to be in laptop also. So what I'm doing trick, because my kubectl is here, okay, is here in the master. So I'll make a master itself as a workstation. So let me see if they have set it up. If not, I will set it up. And see, actually they set it up actually. They set it up my, what do you say, workstation also. Now you'll say, Rajesh, how do they set it up? So actually they did this one. That's the reason I copied it. Okay, so this will set up your workstation. So that means I'll put it in a simple way. Kubelet required one file which is called config file at a location which is here. So this script, okay, I'm using after 2 months actually. This script is copied and did this for me. So that means this master is also acting like workstation. This command is working. See, there's a master and ready. Understood all of you?
Yes.
So don't get into the complexity right now, because I don't want you to get lost. So you set it up, wonderful. Workstation is done, wonderful. Now I need to set up a worker. So for worker, what is the IP address? Here it is. See, by mistake, did I set up a, just a second, hold on. I am lost, 191, 190. Okay, see my mistake. I set up a master in worker, and this is a worker actually. Okay, so now I'll go and connect to the worker. And here, something which I'm not doing, don't get into those topics, because I know that easily you will lose the interest if you find difficulties. That's a problem. So only the things you do blindly, what I am doing. So at least you will have some success. And once you test the success, you will have a curious for more success. So then you will try, and then you will feel, then that's okay. So Ubuntu, and then here. Now same thing I'm going to do. Get the script cloned here. This is a shell script, so you can read it offline if you really want to know its steps and all. CKS cluster setup, latest, and let me give the permission to install worker, chmod 755 and install worker. So I'm installing the worker. It will take the same amount of time. The only difference between the worker and master.
Sorry for the interrupt, Rajesh. Like whatever the commands we are running to set up the worker, node. So like where do we get these commands?
Which command?
Like whatever the commands we are running to set up the worker node, right?
I'm showing you the same thing. No, I'm downloading this script from
Yes.
this repo.
Okay.
I'm doing okay. Yeah. See, all this script I'm downloading and running it. Now, what exactly these commands are there in shell scripting? In detail, you find out one day and see the logic inside. Okay.
Sure. Okay. Okay.
So right now, I want you to use the Kubernetes rather than getting into the configuration issues. So in the worker, the only thing is you will have this component only created. Only proxy will be there. This anyways you will store and like that. Now this command you have to run in the worker, else it will not detect. See here, there's a master node ready and worker node will be coming. See here, please read this, don't rush. So here they are saying, hey, whatever the command you got it, no, run it. So I'm just running it. Enter. I just ran it and it should be done by now. Done. Now this command they are asking you to run in the workstation. So here, see, you got it. Additional machine here, you got it, right? Now it's not ready. Just wait for it. Have a little patience. See, yeah, it's done. So this is something which we have it. So now we have set up a cluster and everything is ready to start. Any questions so far, guys?
After installing the master and worker, we use few control get nodes, then we get the nodes, right?
Yes, yes, you have to do this. Okay, so this is the setup. So I talked about what is Kubernetes, why Kubernetes, how to set up a Kubernetes with the latest version with the container D and all stuff like that. Guys, I need a one break for 10 minutes. I just want to go to the restroom. So can we have a break right away and we'll connect after 10 minutes?
Sure.
Yeah. See you guys.
Thank you.